Hi everyone and welcome to my latest soldering tutorial. As always, thanks for tuning in. Now this video basically is another one in a series of videos I've been producing. Each video is going to be basically dedicated to one type of component. I've already posted a surface mount resistor one, so this one's going to be solely dedicated to surface mount capacitors. Now I've got a few different types on your screen, as you can see. So down the left hand side I've got these electrolytic capacitors, got different package sizes, so sort of 1206, 0805s, 0603 here, so going down to 0402 down the bottom here. Got these variable trimmer capacitors, so I'll sort of talk you through them, how to solder them, how to sort of clean them properly. And so on the right hand side I've got these different sizes of tantalum capacitor. So what we do throughout the video, we talk about the polarities, how you check your polarities, sort of how you can get great soldering joints on all these. I'll show you the methods that I use to get really good results. So we sort of do's and don'ts throughout the video. We'll also put a few photos up along the way. So what we do, we get straight on with the first part and we progress through all these. Yeah, hopefully you enjoyed the video and learn something from it. So what we do, get straight on with the first part now. Quickly before we move on to the soldering stage, and talk you through some of the markings and the polarities on the top, some of the codes. I'll start down the bottom here. Got the variable trimmer capacitor. Now this particular type's got no polarity. The green stands for 30 PF, that's the maximum this can be adjusted to. So these are sort of valued in colour. Now there's a black one that's maximum of 3 PF, there's other colours in between. So that's that particular type of range. So you've got the tantalum capacitor in the centre, the orange band's your polarity, so that's the anode, the positive end. 227 basically stands for 220 UF or 220 microfarads. A stands for maximum breakdown voltage. This one's rated at 10 volts. Where you got the 106E, so basically your 106 is a 10 UF. It's obviously the 7's got an extra 0 to the 6, that's a 10 UF. That's your polarity. E is just the breakdown voltage again. There's a chart of all the sort of codes online if you need to see all the sort of breakdown voltage values. And then we come to these electrolytic capacitors up the top. Now you've got your black band there, that's the polarity marking, that's your cathode, the negative end. So up the other end you've got the chamfer in that right hand corner, that's your anode, the positive end. So you can see the one up the other end is basically 10 UF, 16 volt. Where that hasn't got a black band, go by the chamfer, that's your positive. So this one here is basically 100 UF, and V is your breakdown voltage. Like I say, there's a chart of all the breakdown codes. So that's basically it. So that's check the voltage breakdown letter there, your polarity marking there. And yeah, hopefully this little guide's helped. You can always find this information out online. So what we do now, move on to the soldering stage and we'll get some of these soldered up. Right, so we're going to start the capacitor video. D-size tantalum capacitor. And remember the orange band is your anode, that's a positive. 227 is basically the values. This one's 220 UF or 220 microfarads. A was the breakdown voltage, so there will be the chart up with all the letters and what the voltages we sort of are compared to the letters. So basically, on some of your boards you will get a positive symbol, but on some of them you will get this chamfered silk screen bar. So I'm just going to tilt the board up slightly so you can see that a bit clearer. So you've got the chamfered bar up the top end, and that is your positive. So just match the orange line up with a chamfer or the positive symbol, and your polarity will be correct. First thing I'll do now, what a lot of people do, I've seen quite a few people do, what they do, put a giant blob of solder on this end for instance, enter the component into the solder and then do the other end. Now that's fine for some hobbyist sort of jobs, but when you're getting smaller and smaller and smaller, if you want to get your sort of soldering really neat, this method works for me, so it's totally different from that. So yeah, hopefully this can help you out. Basically what you can do, get your component laid in position. So, yeah, so always check your polarity. Then I'm going to add some rework flux to both ends. So I always use a plastic cable tie to enter some flux onto the pads, so you won't get no scratching using this method. And then get this soldered up. Now I'm using lead-free solder, 0.25. You can use 0.5 for these size components. Just I've got 0.25 near me, so I'm just going to use that. So I get all my solders from BLT Circuits in England. So what you do is get a small amount of solder, and we'll get this end tacked in position. Then we'll do the other end properly, and then we'll revisit the first end and do that properly. Like I say, just get a small amount. Make sure your component's central. Hold it central. Just get that tacked in position. Keep it there until the solder's set. And what we'll do, go to the other end and do that properly. When I've cleaned it, I'll sort of turn the component around and show you the other end. But for now, I'm just going to solder this up properly. So you don't want too much solder, just want a nice fillet, a nice curved joint. And go back to the first end and now do that properly. So I always say, all my videos, if you can get this nice consistent curved joint, you're going to definitely improve your soldering. So that's all you're looking for. I'll probably keep saying it a bit too much. Get that curve nice and up and hold sort of tab of the joint, and that's what you're looking for. So what I'll do, I'll clean this up and then I'll sort of turn it round and show you the other end. So remember, get the polarity right, get these sort of joints, and you'll definitely be able to go smaller. And that's where we're going to go next. We're going to go to a smaller size component, another tantalum, and then we'll sort of progress through the other capacitors. And we're going to finish up with quite a small one. And then I think after the small, we're going to do basically a 402 near the end. Then the last one will be the variable trimmer capacitor. So what I'll do, I'll clean this up and sort of show you the end results of this one. Right, just quickly, I've just cleaned this up, turned it round. As you can see, got that lovely curved joint, and right up the face. That's perfect amount. Remember, so the chamfered silk screen band refers to the positive, that's the anode. So anyway, what we're going to do now, move on to another tantalum, a smaller size, and we'll show you that one. Right, so we started with a case D size tantalum. We're now coming on to a case A size. This is equivalent basically to a 1206 size component. Now, as you can see on the top of this one, we've got 225C. Now the reading of this one is basically 2.2 UF, because you've got a 5 after. Now the last one had a 7, so basically move a decimal point 2 spaces to the right. That's how we got 220 UF on the last component. So this one's 2.2 UF, or 2.2 microfarads. So basically you will get to learn all these codes. They're quite easy to work out in the end. So what we do, just going to add some rework flux, same as before, and we'll show you how to get this one soldered on. So I'll just get my trusty plastic cable tie to add the flux. Just place the component back on, and away we go with the soldering. Now I'm doing this one with lead free, so I've got my iron set to about 375 degrees Celsius. So again, as you're going to see in all the demos, we're going to do a consistent method. So just going to get it tacked on one end. Main thing, get the component nice and central on the pads. So it's got a small amount on that. I'm just going to do the other end properly, then we'll revisit the first end. I'll turn it round a minute so you can see this joint. So I just want a small amount of solder. We'll just come back to this end now. That's all you're looking for. It's got a lovely curved joint up the front. You don't want to go too much on these. If you can control your solder on these larger ones, like I keep saying all the way through sort of all my videos, it will really benefit you in the future when you get to your smaller stuff. I'll just give this a quick clean, and I'll turn it around and show you the other end joint. So the wipes I use are G-Tech dry wipes from a company in England called Grove Sales. Together with the Ultrasolve cleaning fluid, do a great job. Basically, try and turn this around and show you the other end. You've got just a small amount on there, just curved up the back. That's all you're looking for. So it's round the bottom, slightly going up the tab at the end. That's all you're looking for. You don't want a bulbous joint. As you can see, that's the perfect amount for that device. So what I'm going to do now, we're going to move on to the next component. We'll show you a consistent method, and yeah, we'll go through the others after that. Right, so moving on from the polarised tantalum capacitors, come to this standard type of capacitor. It's basically a 1206 size, no polarity on these. Probably the most common type of capacitors you probably see. Got all different sizes in these, 0402s all the way up. This is actually, like I say, a 1206 size. What we're going to get it fitted to these two pads. This pad here is connected to this sort of plane going around here. So just a bit more patience is going to be required on that joint. It will take a little bit longer. You can always sort of up your iron size or up your heat slightly on your iron. So anyway, what I'm going to do first, add some rework flux underneath. So just get some of that across both pads. So flux is really vital when you're soldering. You won't sort of get good results if you don't use it. Lay the component on the flux and yeah, ready to start soldering. Like I say, probably a little bit of patience needed on that front joint. Just get a small amount on your iron tip, get that centrally tacked on, as always, as the other methods. Just hold it at the base, just be patient, it will take slightly longer. So that's that tacked in position. Nice and central, just got a small amount on that. Now I'm going to try and turn this round, hopefully I'll get the other end in view so you can see that being soldered. Probably most I can go, so I need to get my iron tip down in that gap. So what we do, we get some soldering now, turn it around sort of just a little bit more after so you can see the joint. So just lay your iron on the foot of the component. Get that soldered up. So you don't need too much, just that small amount, that small curve. Hopefully if I can spin that round slightly more. Hopefully you can see can't really go much more. So you've got a small amount around the base of that. And then we go back to the first end and we get that finished off. I say this one will take maybe slightly longer because of that plate attached to C52's plane. So a little bit more rework flux in front of that, and then we'll get some more solder added. Just lay your iron across the joint, wait for it to sort of melt, and then start adding solder. There you go, it's going. You just add it there, take your iron away. We've got a nice result. As you can see, you've got a nice amount around the base. Get a real quick clean, and hopefully you should see that clearer. I say there's a few different, you will get to learn when you get attached to sort of ground planes and stuff. There is ways around it. So you can always up the temperature on your iron. This is lead free. My iron's set to about 370 degrees Celsius. But I sometimes vary that sort of slightly for different types of scenarios. That's what you're looking for. Got a lovely joint, perfect amount. So that's a good result. So anyway, what I'm going to do now, I'm going to put a few photos up of these first three, and then we move on to some different types of capacitors, different package sizes. Yeah, hopefully you enjoy them as well. Right, so moving on with the videos, this is in the second half, we come on to the electrolytic capacitor. Now, basically this one's going to fit in this position here, and I'm just going to tilt the board up. Just want to show you what I was saying about earlier about the polarity mark. So you've got your chamfer there on the corner, obviously the same over that side. So this is the positive end, so if you haven't got a positive symbol on your board, go by the chamfer. So basically, yeah, this end's connected to the plane, the ground plane negative, so soldering might take little while longer. Now if you've got sort of untinned pads on your board, what you can do is tin this up, solder wick it all off, and when you do the soldering it's going to flow under the device better. But with this one, it's already got the solder on it, so yeah, we just lift the component on, get this soldered up. So obviously you put it on the correct way round, So chamfer matches the chamfer. So this particular device, saying about earlier, this is 100 UF on the top, and the V was the voltage breakdown, so that's 35 volts is V. But say earlier, there will be a chart up sort of showing the voltages. Alright, so I'm just going to get some external flux added to them pads, and then we can start the soldering. So just put a small bead of flux on both ends. That just aid the solder running under the device. So there's lots of different sizes of these electrolytic capacitors. This is sort of a medium size. Right, let's get that soldered up. So I'm doing this with leaded solder. So again, 340 degrees Celsius. All you need, as in all the other videos, a tiny amount on the first end. Get that tacked on, then do the other end properly, and then revisit the first end. As you're sort of seeing, all the methods are consistent, but you're always getting the sort of same result. So just get that tacked on nice and flat, and turn it around, do the other end properly. Hopefully I'll keep it in shot, and you can see the other joint down there. So what you're looking for, I like to see the outline of the pin, but basically hold your iron on there for a short while. The solder will flow underneath, and you should get a joint right along that sort of the tab of the device going underneath. So let's get some solder on there, and yeah, just hold your iron on there, let the solder run underneath so you get a good joint. You don't just want to blob on the end. If you hold it on, keep feeding it in. Once it starts loading up too high, that's the time to take your iron away. Right, so I've got a nice amount on the end there. As you can still see the outline of the pin. That's the perfect amount. So plenty of solder went underneath the time I had it on there. Just now come back to the first end, and we get that finished off. Just try and get that in view. Just going to zoom in slightly for that. Right, let's get that soldered on. Sometimes in the end of the pin, right on the end of the pin, sometimes the solder doesn't take perfectly, but it normally does, but you might get the odd time when it doesn't. That's fine, the solder is going to be plenty loaded up underneath. Just going to turn it around a slight bit more. Right, let's get going on that end. So again, just hold your iron on there for a short while, let the solder travel underneath. Just need a bit of patience. So you don't want too much. You're going to get a nice fillet if you hold it underneath. And that's a perfect amount. Let's try and zoom in on that. As you can see, you can still just see the outline of the pin of the device. And that's what I like to see. So I've got plenty going underneath for the time we held the iron on there and fed the solder in. And that's basically how I do my electrolytics. So all the sizes do exactly the same method. Like I was saying, if you've got untinned pads, particularly gold sort of coloured ones, you will sort of struggle to get the solder flowing underneath. So if you want to tin them first, get your solder braid, wick that off, and then the solder is going to travel so much easier underneath. So that's yeah, that's what you're looking for. Got a lovely shaped joint, pin's still visible. So that's how I do my electrolytic capacitors. So what we're going to do now, we're going to move on to an 0603 size device, and yeah, we'll get that one soldered up. Right, so moving the size again with the capacitors, come down to the 0603 size. Now I've got two that I'm going to do in this demonstration. I've got C53 up here and C40. So I've already added some external flux just around the pads just to speed the video up. So again, same method as all the others. Just get one end of each tacked in position. Just get central on the pads. So to get a small amount of solder on your iron tip. So basically try and get the component centrally in the pads. And this will sort of put you in good position when you get smaller components. Always try and get it central no matter what the size. So this pad here is attached to this plane around here. So when you get a pad like that, you will need a little bit more heat, might take a bit more patience. So what you do now, go to the other end and get that soldered on properly. Just aim for that nice curved joint that we showed in the other sizes. You don't need too much solder. If you can get these nice and curved, when you do the smaller stuff, it's really gonna aid you. And basically revisit the first end and get that soldered up properly. So just look for that nice curve. You should have 4 nice joints there. I'll clean this up in a sec so you can see even clearer. So that's what you're aiming for, a nice curve, as in the other methods. So you don't want a bulbous joint. So if you can get joints like this, when you get to the smaller stuff, it's really going to sort of benefit you. I'll just quickly get some of the flux cleaned off and hopefully you can see these joints nice and clearly. So I said earlier, basically all the sizes, all different sizes, always the same method. So this is the way that works for me, and yeah, hopefully it can help a few other people. So that's basically what you're looking for. You've got a nice perfect curve top to bottom, all 4 joints. I'll put photos up the other end. It's quite hard for me to turn this around and get it in focus. So yes, that's basically what you're looking for. Just be consistent with your method and you won't go far wrong. So anyway, right, so move on now to a variable trimmer capacitor. Now I'm going to place this on C5. Now polarity on these doesn't tend to matter in a lot of cases, but occasionally if you've got an RF board, for example, outside influences may affect the workings of it. So I would always put that chamfer to the positive, but like I say, it doesn't matter in a lot of cases. But yeah, if you put the positive to the basically the chamfer, you won't go wrong. So basically what I'm going to do is place it on C5. I've already pre-fluxed the area, so I want the joint to go fairly quickly on these. So what I'm going to do with this one, I'm going to preload my iron with sort of the right amount of solder that I believe will do a good joint, and we're just going to go in with that. And yeah, I'm not going to add any extra. So what I'll do, get the component placed in position. I'm using leaded solder for this because I want a nice quick joint. So I'm going to, like I say, I'm just going to get the right amount of my iron that I believe will sort of do enough to flow underneath the joint, and hopefully we get a good result. So let's hold the component central, put your iron on there, hold it for a short while. Solder should flow underneath because of the flux, and that's quite a nice joint there. Got a nice curved joint like all my other sort of methods. So that's what you're looking for. So the body's fine, you don't want to get any cleaning fluid or any flux on this top part, the adjuster part. So yeah, avoid when you're doing the cleaning, just carefully wipe around the bottom, don't get anything inside. So what I'm going to do now, I'm going to turn it round. Just before I do that, these components are basically colour coded. Like greens, this particular range green is 30 pf, maximum 30 pf adjustment. So, and yeah, that's the highest one in this particular range of components. These components also tend to work basically in just PFs, picofarads, so quite a small capacitance on these. So yeah, basically when you get a range of these, you will sort of learn the colours. So anyway, what we'll do now, I'll get it turned round, and yeah, we'll get the other end soldered up. Right, so I've turned the component round, so we're now going to go into this joint here, get that flowed. Now this is basically a negative end, so this pad is connected to this plane around it, so the soldering will take slightly longer, but hopefully we'll still get a good result. Like I sort of done the method a minute ago, to get the right amount on your iron tip that you believe should do a nice joint, and yeah, we'll just go in to the pin and try and achieve that joint. That's the perfect amount there. Go nicely underneath, up the end, just very slightly over the top. That's a really good result. So basically, yeah, when I clean this, I'll just quickly clean this end. I'll show you how to do it. I've got my cloth and my tweezers. I'm not going to get anywhere near that top part. So just carefully get my tweezers and just really carefully wipe around the bottom. We don't want to get any near that top. And hopefully you should see a nice joint there. Just going to slightly zoom in. I've got a nice curved joint, and that's what you're looking for. So hopefully, yeah, you've seen how to fit these variable trimmer capacitors. They're not very sort of common, never use that many, but occasionally you will get them. So yeah, if you put the chamfer to the positive, you won't go far wrong. Anyway, what we're going to do now, we're going to move on to the final capacitor in these videos, the 0402, and we'll show you how we do them. Right, so move on to the last component within these videos. I'm going to show you quickly how to do some 0402s. Now, I've got two locations up here. It's going to fit a couple of components across there. Now, I've already pre-fluxed this area just to sort of speed the video up. Now, I've spoke about this method in other videos. You've got two choices here. You can try and get the right amount on your iron tip to do the first end in one go, so you get a nice curved joint. Or you can do as I've shown in the other videos, you can tack one end on, do the other end properly and revisit the first end. But for this one, I'm going to try and judge the right amount on my iron tip and try and do sort of end one in one go. So I've already added some rework flux just to speed the video up, like I say. So what we do, just drop the two 0402s in position. Just going to nudge them off my tweezers because they seem to be stuck to my other tweezers. Right, so I've got two of them roughly in position. Now, I'm going to get that first end, try and do that in one go. You will get to judge the amount once you've been doing these for a while. Right, see if I've got enough on there to do it in one go. Right, I'm going to do the bottom one first. So centralise your component. Let's go in with the iron tip. So I've got a nice curved joint there. I'll clean all these up after, like the other methods, and show you the results. So what we do now, try and get the same amount in your iron tip and do the other component. It's worth just taking a short while just to get the right amount. Right, let's go in with the second component up the top. Again, centralise the component. You should get two nice curved joints. Hopefully you can see them there. Just going to try and zoom in slightly. So hopefully you see quite a good result there. Got two nice joints. I'll show some side angles with the photos. And that's I'm really happy with them two joints. What I'll do now, I'll turn these around and we'll get the other two done. Right, so as you can see, I've turned the board round and there's the two unsoldered joints of the 0402s. So we're going to get them two soldered up now. And we'll do the same method on these, try and judge the amount on my iron tip. You can feed the solder in, as I've showed in the other methods. I've showed that in other videos as well for 0402s. Basically with this one, I'm just going to try and get the amount judged on my iron tip again to get the joint in one go. So I'm doing this with leaded solder, about 340 degrees Celsius. Let's try and get that amount judged and try and get these done in one go. Right, so I've got about the right amount for the first one. So again, just gently go in. And we've got that nice curved joint there. I'm going to go in for the second one now, try and get the same again. So you don't really want to put massive blobs on these. If you can get these right, your soldering's really going to improve. It can really help you do fine pitch ICs. Right, let's get going now with the second joint. So I've got about the right amount of my iron. So I'll bring my iron in carefully and let's get the joint done. So as you can see, I've got another nice curved joint. So again, I'm really happy with them two joints there. You can see how small these are because the size of my tweezers. These are quite small tweezers as well. So that's a perfect joint. So what I'll do, I'll get these cleaned up. We'll take a few photos as always, put some up at the end. Anyway, I hope you've enjoyed the videos and hopefully you've learnt something from them. I'll do a few more of these tutorials, including diodes and crystals, for example. So anyway, I hope you get on well with your soldering. So until next time, thanks again for tuning in. It's really appreciated and I'll see you again soon. So take care.